Okay, so today is 8.1, Intro to Sine and Cosine Curves. So you need the guided notes for this lesson, so if you have not gone to the folder and gotten the guided notes, please do so. Okay, so today we're going to be talking about how the unit circle actually can help us create a sine function and a cosine function graph. Okay, so if you remember, and you can actually take out your unit circle if you want, right? We have our coordinate plane, and we know that this was 0, pi over 2, pi, 3 pi over 2, and then if we go all the way around, it's 2 pi. And then if you remember, we had these points here, right? And they're on your unit circle. Again, you can take out your unit circle if you want. This point was 1, 0. This was 0, 1. This was -1, 0. And this was 0, -1. Okay? So what we're going to do is we're going to actually fill out this table right here. We're going to find, for example, in this first box, we're going to find what the cosine of -2 pi is. Okay, so if you remember, in a coordinate point, the x is the cosine and y is the sine, right? So if I'm trying to find the cosine of -2 pi, if you remember, when we have negative, that means we go like downwards. So -2 pi is going to be a whole circle. So we're going to land at this point. So the cosine of -2 pi, well, we care about the x value. So that's going to be 1. So I'm going to put a 1 here. Now the cosine of -3 pi over 2. So that means I'm going to go 3/4 of the way around, right, like here. So I'm focusing on the point 0, 1, and the x value is 0. So the cosine of -3 pi over 2 is 0. Okay, now I'm doing -pi. So that is just a half circle, and so the x value at this point is -1, and then if I'm doing -pi over 2, that's just a quarter of a circle, and again the x value is 0. And then if I don't move at all, right, we're then focusing on this point right here, so the cosine of 0 is just 1. And then the cosine of pi over 2, now again, it's positive, so I'm going this way. So cosine of pi over 2 is just 0. Cosine of pi is just -1. Cosine of 3 pi over 2 is 0. And the cosine of 2 pi is 1. Okay? Now we're going to do the same thing, but we're going to focus on sine. So we're going to go kind of like, we're going to focus on the y values now, okay? We're going to focus on the y values now. So again, we're doing sine of -2 pi. So I'm going to go downwards all the way around. And the y value, I'll use a different color, is 0. Okay? Now, if I just go 3/4 of the way around, the y value is 1. If I go halfway around, the y value is 0. If I go just 1/4 of the way around, the y value is -1. If I don't move at all, again, the y value is 0. Okay? And then if I go to pi over 2, so now I'm going the normal direction, the y value again is 1. If I go halfway around, the y value is 0. If I go 3/4 of the way around, it's -1. And if I go all the way around, the y value is 0. Okay? So here I have my two, like, cosine function and sine function. So what we're going to do now is we're going to actually graph it. So if I were you, I would use 2 different colors, okay? And so we're going to label it. We're going to label this 1 and this -1 here. So I'm going to start by graphing the cosine, okay? And I'm going to use green to graph it. So when x is -2 pi, the y value is 1. So here's my first point. When x is negative 3 pi over 2, the y value is 0. When x is negative pi, the y value is negative 1. At negative pi over 2, the y value is 0. At 0, the y value is 1. Then it's pi over 2. At pi over 2, it's 0. At pi, it's negative 1. At 3 pi over 2, it's 0. And at 2 pi, it is 1. So when we connect, we want to make a curve like this. Okay? And this is what we call our basic cosine curve. So this is y equals cosine of x. Now we're going to do the same thing but with sine. So again, now I'm focusing on this row. So at negative 2 pi, the y was 0. At negative 3 pi over 2, it was 1. At negative pi, it's at 0. Negative 1, it is, at negative pi over 2, it's negative 1. At 0, it's 0. At pi over 2, it's 1. At pi, it's 0. At negative 3 pi over 2, it's negative 1. And 2 pi, it's 0. So again, I'm going to connect it using a curve like this. And this right here is my sine curve. So I'm going to label this as y equals sine x. So I really hope you use different colors. So we're going to answer these questions and then the video is almost done. So what is the domain and range? So remember, domain are all the possible x values. And so if you notice, it goes on forever. So our domain is actually negative infinity to infinity, right? It just goes on forever. So that's the domain. Now for the range, if you notice, it doesn't go above 1 and it doesn't go below negative 1, right? It ends here and here. So our range is actually negative 1 to 1, right? It's constrained between that range, okay? And so this next part is, it says, after how much horizontal distance will both sine and cosine repeat its pattern? So let's focus on the cosine. So here we start with the max, then we have a 0, and then we have a min, then we have a 0, and then we have a max. And then if you notice, it starts the pattern again. It's a max, a 0, a min, a 0, and a max. So if you notice, the distance of one pattern is 2 pi, okay? So the pattern repeats every 2 pi, right? So here was 2 pi, and here was 2 pi, right? And so this is why we call it a periodic function, because it like cycles through, right? So every 2 pi, the pattern starts again. And so the way to differentiate between cosine and sine is you kind of just have to be aware of the patterns. So I'm going to write out the patterns and then I'll show you why these patterns are. So the pattern for cosine is max, 0, min, 0, max. And the pattern for sine is 0, max, 0, min, 0. Okay? So if you look at the y-axis right here, if you notice, the cosine function, which is in green, starts at a max. And then it goes to a 0. And then it goes to a min. Then it goes to a 0. And then it goes to a max. So that is why this is the pattern. This is one pattern. Okay? And then, again, if you focus on the y-axis again, at the y-axis, the sine is at a 0. Then it's at a max, then it's at a 0, then it's at a min, and then it's at a 0 again. So that's how we get this pattern here, 0, max, 0, min, 0. So this is the pattern for sine, okay? So this is what we call the basic sine and cosine curve. You know that it follows these patterns here, okay? So what we're gonna do now is we're gonna explore what happens when we add a coefficient to the front. And I'm just going to introduce this to you, but mainly you're going to be doing this by yourself. I just want you guys to know how to do this, okay? So what we want to do right now, they've graphed a basic cosine curve, right? And we know it's a cosine curve because at the y-axis, it's at a max, right? So that's why I know it's cosine, because cosine starts at a max, okay? And I want to graph y equals 3 cosine x, okay? So what you're going to do is you're going to go to Google Classroom. And if you notice, I posted something called graphing trig functions. You're going to go there. You're going to go to the Desmos link. You're going to click it. Going to continue, and you'll see that we kind of have like a graph already ready for you, okay? So what you need to do is you just need to type in what you're trying to graph. So we're trying to graph y equals 3 cosine x. So y equals, let's see, can I do this? Y equals, ooh, I don't know how to type. Okay, 3 cosine of x. And so if you notice, okay, so if you notice, it starts at 3, then it goes to a 0, then it goes to a min at -3, then a 0, and then a max. So I'm going to graph that here. So 3 cosine x starts at a max at 3, then it went to a 0, then it went to a min at -3, and then a 0, and then a max. And then I can repeat the same pattern, right? So here is now the graph of 3 cosine x, okay? So what I want you to do, I'm going to end the video, but ask questions if you need help, is now keep graphing these other ones on the same graph, okay?